Alright, today's topic is called the fundamental theorem of calculus. With a name like that, you'd think it might be pretty important. We've done intervals, we've done indefinite integrals with plus c on the end, and we've used Riemann sums to estimate area under a curve. Today I'm going to show you how to find exact areas under a curve using the fundamental theorem of calculus. Alright, so we're given the interval from 0 to 3 of 2x. So here's a picture of what we're talking about. We want the area under the curve of the line 2x from 0 to 3. So this area right here. We know from geometry that that is 1/2 times 3 times 6. It's going to be an area of 9 units squared. Okay. Over here, let's use calculus to see if we can find the same answer. We know how to integrate. We're going to add 1 to the exponent, and so that's going to wind up being x squared over 2 times 2, times 2 right there, and we're going to evaluate that from 0 to 3. That's what f of x is going to equal to. Add 1 to the exponent, divide by that exponent, 2 is already there. What that means to us, we want to evaluate f of 3 minus f of 0 to find the answer. Well, f of 3 is 2 times 3 squared over 2, which will cancel out actually. So that's 9 minus f of 0, which is 0 squared. So that would be 9 minus 0, which is 9. And that matches our answer. Alright, in this problem right here, we actually have two pieces we're going to integrate. We can integrate each one independently of each other. They're treated as monomial terms. Over here I have a picture of the graph coming up right here. Now it's a curve, so it's a little bit under where that triangle would be right there. The triangle would have been 1/2 times 2 times 8. So that would have been an area of 8 units squared. This should be something just slightly smaller than that. So we're going to integrate each piece. And so that's going to be x cubed over 3 plus 2x squared over 2. They will cancel. So there's my equation right there. And I want to evaluate that from 0 to 2. So what I'm saying is that I want f of 2 minus f of 0. Well, f of 2 is 2 cubed over 3 plus 2 squared over 1. So that's going to be 8/3 plus 4 minus, okay, so it's f of 3 minus f of 0. F of 0 is 0 plus 0, so that's just going to be 0 right there. It's going to 8/3 over 4, and that's going to wind up being 4 is 12/3, 20/3 for my area under the curve. Well, 20/3 is just a little over, just a little under 7 units. So we have a slight 7.6 repeating, I believe. And so what we have here is an area slightly 6.6 repeating. I'm sorry, 6.6 repeating. So an area slightly under the 8 units we expected to have right there. Okay. So look at this function right here. We're integrating the cosine function from 0 to pi. Again, we're going to integrate this. So f of x is going to equal to the integral of cosine is negative sine. We're going to evaluate that from 0 to pi. So before we go any further, let's go over here. This is the graph. We're going to split this area right here. This area is all positive. This area is all negative. And they look to be the same size. So we might expect to get an area netted out to 0 over here. Again, above the x-axis is positive, below is negative. So over here, when I evaluate this, that's going to be negative sine of pi minus negative sine of 0. Well, sine of pi, well, that's 0. And sine of 0, well, that's 0. So sure enough, we want an area of 0 units. And again, it's because half of it was positive and half of it was negative. And finally down here, we're going to integrate this guy. Might be easier to look at the 2 up front. Sometimes it's easier to take the constants out in front so you see what you've got. Okay? So that's the integral from 1 to e of 1 over x. Now, if I integrate that, before I integrate, let me rewrite this one more time. This way. Okay? I can turn fractions into negative exponents. If I integrate that, I'm going to get 2 times, well, the integral of that is going to be x to the 0. Okay? Don't know if I told you or not, but anytime you want a 0 exponent, that means you have a natural log function. So f of x equals 2 times the natural log of x. That's what anything with 0 power means. And we're going to evaluate that from 1 to e. So what I want is 2 times the natural log of e minus the natural log of 1. Okay? Now, the natural log of e is 1. The natural log of 1 is 0. So we wind up with an area of 2. In this graph over here, what we're talking about is this shape right here from 1 to e right there. So that area right there, we want to make an area